morning, students. 12th English, chapter number 7, Alternating Current. We will see some MCQs. Okay. First of all, how to solve MCQs. You have to understand question. Okay, what is question? Okay. Yes. From chapter, first of all, make a list of all equations. Make a list of all equations. Okay. And then after, with the help of that list, you can easily solve such questions. Okay. Yes, we will try here some questions. Okay, how to solve MCQs. Okay. How to write in detail and how to write in short. Okay. See, first question is, which is based on power. Yes, which is based on power. Power in AC circuit. What is its equation? What is power factor? Okay, that we will understand with the help of one question. See, here it is. An alternating current, an alternating voltage V is equal to 200 sin 100t is applied to a series combination of R is equal to 30 ohm and an inductor of 400 millihenry. The power factor of the circuit is. Now, yes, first question. Okay, sir, what is power factor? What is power factor? So here I will write, see, what is equation of power in AC circuit? Equation of power in AC circuit is P is equal to Vrms IRMS cos phi, where cos phi is equal to R upon Z is called this cos phi. Okay, this cos phi is called power factor. Okay, and it is equation. Okay, how to find power factor? So understand, power in AC circuit P is equal to Vrms IRMS cos phi, where cos phi is equal to it is R upon Z is called power factor. Cos phi is equal to R upon Z is called power factor. Okay, cos phi is equal to R. R means resistance. Z, what is Z? Z is impedance. Z is impedance of circuit. Z is impedance of circuit. Clear about this? So first of all, you must know what is equation of power. Power in AC circuit P is equal to Vrms IRMS cos phi, where cos phi is called power factor. Cos phi is equal to R upon Z, where Z is impedance of circuit. Circuit, you will be given which type of circuit you are given. See here, identify data. An alternating voltage V is equal to 200 sin 100t is applied to a series combination of R is equal to 30 ohm and an inductor of 400 millihenry. Means here you are given RL series circuit. You are given RL series circuit. Okay, the first step is to find what is impedance for RL series circuit. See, remember from theory. Okay, for LCR series AC circuit. For LCR series AC circuit, what is impedance? Okay, yes, impedance Z is equal to, it is under root R square plus XL minus XC whole square. Impedance Z is equal to, it is under root R square plus XL minus XC whole square. Where what is XL? Yes, you know what is XL. Where XL is equal to omega L. It is called inductive reactance. It is called inductive reactance. And XC, it is called 1 upon omega C, that is capacitive reactance. You clear about this? So first of all, for LCR series AC circuit, you have to remember impedance. From this, you can write equation of impedance for any series connection. For any series connection. For example, here you are given RL series circuit, means there is no capacitor. Okay, so for RL series circuit, you have to take XC is equal to 0. And if you take XC is equal to 0, impedance Z is equal to, it is only under root R square plus XL square. Yes, R square plus XL square. Yes or no? Yes, it is. So impedance Z is equal to, it is under root R square plus XL square. Okay. So yes, it is that what is concept and how to solve MCQs. You must know all these things. Okay. Here in this question, here it is. An alternating voltage V is equal to 200 sin 100 t is applied to a series combination of R is given. R is equal to, it is 30 ohm. L is equal to, it is 400 into 10 raised to minus 3 Henry. 400 into 10 raised to minus 3 Henry. Okay. Yes. You have to find power factor of the circuit. Power factor. So you have to find cos phi is equal to, it is R upon Z. Chalo, R it is directly given R. But what about Z? So first of all you have to find Z. How to find Z? So Z is equal to, it is under R square plus XL square. R is given, but you are not given XL. Then how to find XL? Yes, XL is equal to, it is omega L. L you are given, but you are not given omega. Then how to find omega? See from this equation. From this equation, you are given V is equal to 200 sin 100. You are given V is equal to 200 sin 100 t. So you have to compare this equation with general formula, that is V is equal to Vm sin omega t. Yes, V is equal to Vm sin omega t. V is equal to Vm sin omega t. Clear about this? So from this comparison you will get Vm is equal to 200 volt and omega is equal to, it is 100 radian per second. Clear about this? So yes, omega is equal to 100. You have to compare. See, Vm 200 sin t, the omega is equal to, it is 100. Clear about this? Okay. So now what is XL? So XL is equal to, it is omega, it is 100 into L, it is 400 into 10 raised to minus 3. So it is 1, 2, 3, 4, and here it is 10 raised to minus 3. So it is XL is equal to, it is 40 ohm. Okay, it is ohm. So what is Z? So therefore Z is equal to, it is under R it is 30 square. Okay, XL it is 40 square. Okay, now you are in class, so you know that Z is nothing but it is 50 ohm. Z is equal to nothing but it is 50. You have to find power factor. What is value of R? It is 30 and divided by, it is 50. 0 cut 3 by 5. It is your answer. Yes. Cos phi is equal to, it is 3 by 5. It is your answer and it is 0.6. Yes. Is equal to, it is 0.6. It is your answer. 0.6. E1. Okay. 0.6. Clear about this? So yes, if you know each and every equation, if you know each and every concept, then you can easily solve this question about power factor. Okay, see, once you know what is power factor, you can easily find if you are asked, okay, what is power factor? The power factor P is equal to, it is Vrms, Irms, cos phi. Yes, what is equation of Irms? Yes, Irms, here I will write, okay, Irms is equal to Vrms upon Z. Irms is equal to, it is Vrms upon Z. Clear about this? Okay, so yes, it is one question that how to solve. Next question, see here it is. An alternating current has both DC and AC components. Components means you have to add them. Okay. So an electric current has both DC and AC component, means current I is equal to AC plus DC. Both components. Okay. DC component of 8 ampere and AC component of 6 sin omega t. So therefore I can write I is equal to AC is of 6 sin omega t and DC is of 8. You have to find IRMS. RMS means root mean square. RMS means root mean square. So it is another concept. Okay, how to find root mean square RMS value? First concept was about power factor. Second concept is about RMS value. Okay, so yes, how to find this RMS value? First of all, first step is to find square. Square. So it is I square is equal to 6 sin omega t plus 8 whole square. So therefore I square is equal to, therefore I square is equal to 6 sin omega t square means 36 sin square omega t plus 64 plus 8 into 6, 8 into 6 into 2 is equal to, it is 96. It is 96 sin omega t. Clear about this? Yes, a square plus b square plus 2ab plus 2ab. Okay. Okay. So here it is. It is square. Now second step is to find mean, means average. So it is I square is equal to average of 36 sin square omega t plus average of 64 and plus average of 96 sin omega t. Okay, so therefore average of I square is equal to, see, 36 is just a number, so it is as it is 36. What is average of sin square omega t? In first lecture of alternating current from NCERT textbook we have derived. Okay, average of sin square over a period is 1 by 2. Simple. Plus 64, hello number. Okay, 64 is constant value, so its average will be the same. That is 64 plus 96 here. And what is average of sine over a period? Yes, average of sine over a period is 0. Average of sine over a period is 0. Remember, over a period, average of sine is 0, average of cos is 0, average of sin square omega t is 1 by 2 and average of cos square omega t is also 1 by 2. Clear about this? Okay, so yes, it is. So therefore, average is equal to 36 by 2, so it is 18 plus 64. Okay, yes, it is 18 plus 64. And that 18 plus 64 is equal to, it is 18. Now, last step, that is you have to find root. So under root I square is equal to under root 82. Under root 82. So root 82 is equal to, it is 9.05. Yes. So IRMS is equal to, it is 9.05 ampere. IRMS is equal to, it is 9.05 ampere. Clear about this? Okay, IRMS is equal to, it is 9.05 ampere, and it is your answer. Okay, to see, yes, two concepts. First about power, second about this one about RMS. How to find RMS? In any question, if you find RMS, first of all square, then find mean, and then find. Clear about this? Okay, so yes, two question, two concept. Okay, yes, see, this is from theory that you have to remember. Okay, but whenever you are solving questions, you have to write like this. Clear about this? Okay, now next questions. Now next question. See, the value of alternating EMF E in the given circuit will be, and you are given one circuit only. Okay, see what is circuit? It is resistor, inductor and capacitor. Means you are given LCR series AC circuit. LCR series AC circuit. LCR series AC circuit. VR means potential difference or voltage across two ends of resistor, voltage across two ends of inductor, voltage across two ends of capacitor. Yes, you are given this three value, and your question is the value of alternating EMF. Means this E is equal to what? This EMF is equal to what? Okay, do you understand question? Now see, at first sight you can say, okay sir, it is very simple question. Yes, if they are in series connection, then we know that for series connection, okay, for series connection, we know that yes, AE is equal to, it is VR plus VL plus VC, means it is 80 plus it is 40 plus it is 100, so is equal to, it is 80, and for 120 plus 100 means it is 220 volt. Yes, at first sight we can say, okay, you can say, okay, yes, it is this, but this one is wrong. This one is wrong. In case of AC circuit, you cannot take directly algebraic sum of voltages across each and every element. Yes, again, in case of AC circuit, you cannot add them directly. You cannot add them directly. Why? Because in AC circuit you have to consider phase difference. You have to consider phase difference. Remember that phasor method. See here, remember that phasor method. Okay. For LCR series AC circuit, current in each and every element is same. Okay. Current is same. So I am assuming it's phasor. Let phasor of current, it is in this direction. It is I. Phasor of current, it is in this direction. And yes, it is in this direction. Okay. So now, chalo, for resistor, remember statement, in case of resistor. Yes, in case of resistor, phasor of voltage and current, they are in same direction. Phase difference between them is 0. So yes, in case of resistor, phasor of VR, it is in this direction. Okay, because they are in same phase. For resistor, V and I, they are in same phase. Phase difference between them is 0. For inductor, remember one statement from inductor. In case of inductor, current lags behind voltage by phase pi by 2. Current lags behind voltage. Current lags behind voltage by phase pi by 2. So VL will be here. VL will be here. And in case of capacitor, current leads voltage by phase pi by 2. So VC will be here. So VC will be here. So see, for LCR series AC connection, this VR, VL and VC, they are not in same direction. They are not in same direction. So you cannot directly add them. You cannot directly add them. Clear about this? Okay, because see, VR, VL and VC, they are in different directions. So this one is wrong. So this one is wrong. Then how to find? See, VR 80, VL 40, VC it is 100. VC is 100. Now see, VL and VC, they are in opposite direction. They are in opposite direction. Okay, then we can say yes, here it is VC. So I can say it is VL minus VC. This one. It is VC minus VL. Okay, VC minus VL. How to write this relation? Like this: E is equal to VR plus VL plus VC. Now as VL and VC they are in opposite direction, I can find the resultant. Yes, VC minus VL. So how to find from figure? See, first vector, second vector, and it will be its resultant, that is E. It will be its resultant, that is E. So therefore E is equal to under root VR square plus VC minus VL whole square. Yes, it is the exact relation between voltages. Okay, so therefore E is equal to under root. E is equal to so then what is VR? Yes, VR it is 80 square plus what is VC? VC is 100 and VR is 40 whole square. So is equal to 80 square plus 100 minus 40 means it is 60 square. So yes, we know its answer. It will be 100 volt. It will be 100 volt. Clear? So remember, you have to consider phase difference. You have to consider phase difference. You cannot add them directly. Clear? E is equal to VR plus VL plus VC. So first of all, take the resultant of VL and VC. It is VR minus VC. Then you have two vectors, VR and VL minus VC. So according to law of parallelogram, E is equal to under root VR square plus VC minus VL whole square. You can easily calculate this question. Okay. So yes, here is one question. This question is for LCR series AC circuit. One can make questions also from RL circuit, RC circuit, different circuits. Okay. So yes, remember about that. Okay. So the next question for today's lecture is: in LCR series AC circuit, resistance R is equal to 200 ohm. R is equal to it is 200 ohm. AC main supply 220 volt 50 hertz. Yes, you know that how to write this data. If you are given AC main supply 220 volt means this value of Vrms is equal to 22 volt and 50 hertz frequency means F is equal to it is 50 hertz. Yes, F is equal to it is 50 hertz. On taking out, now see, you are first of all given LCR series AC circuit. On taking out capacitor, means it becomes RL circuit. Okay, on taking out capacitor. On taking out capacitor means it becomes RL circuit. Current lags behind voltage by 30 degree. 30 degree means it is given phase. Yes, it is given phase. Yes, it is given phase. Okay, then how to find? Yes, okay, phi is equal to it is 30 degree. Phi is equal to it is 30 degree. Now phase. So what is equation of phase? So yes, here side, here this side. Okay, for LCR series AC circuit. For LCR series AC circuit, what is phase difference? What is phase difference between current and voltage? Between current and voltage. Phase difference between current and voltage. Yes. Phi is equal to, or I can say tan phi. It is tan phi is equal to, it is XL minus XC upon R. Phase difference tan phi is equal to, it is XL minus XC upon, but it is for LCR series AC circuit. It is for LCR series AC circuit. If you are given RL circuit, means no capacitor, no capacitance means no XC. Then how to write? Yes, I can write 10. Phi means you are given 30. 10 phi is 10 30 is equal to it is XL upon R. So what is XL? XL is equal to it is R 1030. R 1030. Any doubt? Okay. Next one. Where is this? Yes. On taking out inductor from circuit. On taking out inductor from circuit. So I will write here. On taking out inductor from circuit. On taking out inductor from circuit. Taking out inductor means it becomes RC circuit. It becomes RC circuit. And yes, for RC circuit, you have to ignore XL. So I can write 10 phi is equal to it is XC upon R. See, I want to write only magnitude. Okay, what is relation between XL and XC? What is relation between XL and XC? That's why I am ignoring minus sign. Okay, otherwise you have to consider minus sign. So yes, 10 phi means it is you are given it is 1030 because here again it is given by 30. Okay, so XC is equal to it is R 1030. To see XL R 1030, XC R 1030. So here XL is equal to XC. Yes, remember whenever you are given XL is equal to XC, it is case of resonance. It is case of resonance. It is resonance condition. It is resonance condition. Okay, and whenever it is given resonance condition, in resonance condition, okay, impedance Z is equal to R. Yes, you know, okay, at resonance impedance Z is equal to R. So therefore cos phi, that is power factor. Okay, power factor cos phi is equal to R upon Z, means it is R upon R, means it is 1. So remember, at resonance, cos phi power factor is equal to 1. We have to find what is power dissipated in circuit. So power dissipated in circuit, power P is equal to, we know equation, Vrms, Irms, cos phi. Yes. So is equal to it is Vrms, chalo as it is. Irms means Vrms upon Z. Cos phi here it is 1. But we know that at resonance condition Z is equal to R, means it is V square Rms upon Z is replaced by R. Chalo. Vrms, here it is Vrms, 2201 V square divided by R, it is 200. R it is 200. So how to find this? Yes, I will find it in calculator because I can use it. Okay, 220 into 220 is equal to whatever answer divided by 200. So is equal to, your answer is yes, it is 242. Option A. It is 242. It is 242 what? It is 242. Clear? Okay, so yes, it is one question. See, this question is regarding to phasor. Okay, this question is about phasor. Okay, yes, phase difference between voltage and current is important. Phase difference between voltage and current is important. And this question is about connections. Yes, LCR series AC circuit, RL series circuit, RC series circuit. Okay, only R, only L, only C. There are combinations about this. Okay, so yes, there are 4 MCQs from chapter number 7. Now yes, we will solve some more MCQs to clear your concept. Okay. Now next question, see, in the circuit shown below, The AC source has voltage V is equal to 20 cos omega t, where omega is equal to 2000 radian per second. Amplitude of current will be, amplitude of current means you have to find IM is equal to question. Okay, chalo. IM, what is equation of IM first of all? IM is equal to Vm upon Z. So first question is to find impedance Z. What is value of Vm? Vm is equal to 20 because we can compare. Okay, V is equal to, it is 20 cos omega t. So V is equal to, it is Vm cos omega t. So yes, we can say Vm is equal to, here it is 20 volts. Means it is amplitude. Okay, omega is given. See, figure is resistor, capacitor, inductor, but this inductor is not pure inductor. Okay, pure inductor has only inductance, but it has resistance also. So in this circuit, first of all, how to identify data? First of all, how to identify data? C is simple because C is equal to, it is 50 microfarad. 50 microfarad means it is 50 into 10 raised to minus 6 farad. Okay, total resistance of a circuit means this 6 ohm plus this 4 ohm. So R is equal to 6 plus 4 is equal to, it is 10 ohm. And this millihenry means it is inductance, means L is equal to, it is 5 millihenry. So is equal to, it is 5 into 10 raised to minus 3 Henry. So remember, it is not pure inductor. For pure inductor, resistance is 0. And for pure resistance, inductance is 0. Okay, so yes, you are given RLC and C. From figure it is clear. Okay, it is LCR series AC circuit. So for LCR series AC circuit, first of all you have to find impedance. But before you find impedance, you have to find XL. XL is equal to omega L. So what is omega L? Omega is 2000 into L. L means it is 5 into 10 raised to minus 3. 5 into 10 raised to minus 3. So this 3 and this 10 raised to minus 3. So XL is 10. So now XC. XC is 1 upon omega C. Okay. 1 upon omega C. So it is 1 upon omega. Omega then it is 2000. And C, yes, here it is. 50 into 10 raised to minus 6. 50 into 10 raised to minus 6. Okay, so see, 1, 2, 3, 4 and 5 into 2. So I can write it as 50 into 2000. Okay, 5 into 2, 10. Sorry, 1 divided by, it is 10 into 1, 2, 3 and here it is 4. So it is 10 raised to 4 into 10 raised to minus 6. So it is 10 raised to minus 5. It is 10 raised to minus 6. So it is 10 raised to minus 1. 10 raised to minus 1 if I write in numerator. So it is only 10 ohm. It is only 10 ohm. So XL is equal to XC. Yes. Here you will have XL is equal to, it is XC. XL is equal to XC means XL is equal to XC means it is case of resonance. Yes. Okay. Here XL is equal to XC. Therefore it is resonance condition. It is resonance condition. And for resonance condition, impedance Z is equal to R. And what is R? Yes, R it is 10 ohm. Okay, and therefore IM is equal to Vm upon Z is equal to, it is, so what is value of Vm? Yes, Vm is, it is 20. And what is value of Z? It is 10. So your answer is 2 ampere. Yes, your answer is 2 ampere. Clear about this? Okay, so yes, it is one question, one MCQ, which is based on connections. Yes, remember about this point. Okay, if you are given resistor, capacitor, inductor, but it is not pure inductor, not ideal inductor. Okay, ideal inductor has only inductance. Otherwise, it will have inductance as well as resistance. Clear about this? So yes, 5 MCQs for today. Next MCQs we will solve in next questions. This is it for today. Good morning, students. 12th English chapter 7 alternating current. Yes, today again we will see some MCQs. Okay. First MCQ. An ideal chalk draws current 8 ampere when connected to AC supply of 100 volt 50 hertz. Chalk means what? Chalk means inductor. Chalk means inductor. Ideal chalk means it has only inductance. Ideal chalk means it has only inductance. Its resistance is 0. Its ohmic resistance is 0. So first of all, understand meaning of ideal chalk. Okay, ideal chalk means one inductor which is connected to AC source, which is connected to AC source of 100 volt and 50 hertz. It draws a current of 8 ampere. It draws a current of 8 ampere. Okay. So chalo, first of all, from this data, what we can write? Yes, we can write that is it is inductor, and for inductor we can say that current is equal to voltage, that is 100 volt upon, I can write it is XL. Yes or no? In short, I can write like this: current is equal to voltage upon XL. Yes, XL means it is omega L. Yes, XL means it is omega L, and omega, yes, we will find from this. So A is equal to 100 upon XL. XL is equal to, it is omega L. Omega is equal to, it is, yes, it is 2 pi f. So 8 is equal to, it is 100 upon 2 pi. What is value of f? It is 50, and here it is L. So 50 into 200, this cut, this. So what is L? So I can say that therefore, if I make L as subject, L is equal to, it is 1 upon 8 pi. L is equal to, it is 1 upon 8 pi. From this first statement, I can write this. Okay. Now, next, a pure resistor draws a current of 10 ampere when connected to the same source. Means like this. Okay. If a pure resistor is connected to the same source, resistor, okay, R, resistor R, here it is inductor, okay, with same source means it is 100 volt and 50 hertz, and it draws current of, you are given 10 ampere. Okay, so yes, again from data, how to write? Yes, we know that for resistor, current is equal to voltage, that is 100 upon resistance, means it is R. Upon resistance means it is R. Okay, so now make R a subject, so therefore R is equal to, it is 100 upon 10, and therefore R is equal to, it is 10. So here it is value of R is equal to 10 ohm, and here it is value of inductance, that is L is equal to 1 upon 8 pi Henry. 1 upon 8 pi Henry. Clear about this? Okay. Now next statement. The ideal chalk and resistor are connected in series to AC source of 150 volt 40 hertz. The current in the circuit becomes. Okay, see, now in third case, what is given? The ideal chalk means inductor and resistor. They are connected in series with AC source of 150 volt and 40 hertz. Chalo. Inductance L. What is inductance L? It is 1 upon 8 pi Henry, and resistance R is equal to, it is 10 ohm. Okay, with this 150 volt 40 hertz. Then your question is, what is current in the circuit? Okay, so see, first of all, as it is LR circuit, okay, it is RL series circuit. So we know that what is equation of current? IRMS is equal to it is VRMS upon, as it is RL circuit, it is under root R square plus XL square. But we do not know what is value of XL. So first of all I will find what is value of XL. XL is equal to omega L is equal to 2 by F. 2 as it is, pi as it is. Now frequency, new frequency is 40. So it is 40. And what is value of L? L it is 1 upon 8 pi. It is 1 upon 8 pi. Clear about this? So yes, it is value of XL. It is value of XL. Clear about this? Okay. So chalo. Now how to simplify this? Value of XL is equal to pi cut. Okay. It is 8 and it is 14 to 80. So it will be, it is 10. Simple. Any doubt? Okay. So chalo. What is value of XL? It is 10 ohm. Now we will put value in this equation. VRMS is equal to, it is 150 volt. It is 150 volt divided by under root R. What is value of R? It is 10 square plus what is value of XL? It is also 10 square. Okay, so is equal to, it is 150 divided by 10 square means 100 plus 10 square means 100. 100 plus 100, 200. So it is, its square root is, it is 10 root 2. So 0 cut. Okay, so your answer is, it is 15 upon root 2 ampere. It is value of current flowing from, passing from combination of L and R series connection. Clear? So understand meaning of chalk. What is chalk? Chalk coil means it is inductor. Chalk coil means it is inductor. Clear about this? Okay, from first statement you have to find what is value of inductance. From second statement you have to find what is value of resistance, and then you are given their combination. Okay. Chalo. Now next question. See, what is next question? Chalo. What is next question? As shown in figure, the current through inductor and capacitor are 1.2 ampere and 1 ampere. Current through inductor and capacitor. Inductor means it is IL is equal to, it is 1.2 ampere, and IC means current through capacitor, it is 1 ampere. Your question is the current from generator means this. What is current from this generator? See, it is parallel connection, and in parallel connection we know that potential difference across each element is same. And what about current? So yes, current you have to add, but again in case of AC circuit, we cannot add current directly. Here we cannot write, okay, resultant current I is equal to, it is IL plus IC is equal to 1.2 plus 1 is equal to 2.2. No, it is wrong. No, it is wrong. Why wrong? Because we cannot add them directly. Why? What is reason? See here. First of all, I will draw phasor diagram for this. Phasor diagram. Chalo. How to draw phasor diagram? This inductor and capacitor, they both are connected in parallel connection. In parallel connection, potential difference is same. In parallel connection, potential difference is same. So first of all, I will decide phasor of V in one direction. Now we know two statement get for inductor, current lags behind voltage by phase pi by 2. For inductor, current lags behind voltage by phase pi by 2. So obviously IL will be in this direction. For capacitor, we know that current leads voltage by phase pi by 2. So IC will be in this direction. It is IC. So see, from figure it is clear that IC and IL, they are not in same direction. IC and IL, they are not in same direction. Then how to find the resultant? Yes, as they are in opposite direction, as IC and IL, as IC and IL, yes, IC, see, it is C, okay, as IC and IC and IL, they are having phase difference 180 degree, phase difference 180 degree. So therefore resultant current I is equal to, as they both are in opposite direction, how to write? Yes, it is IL minus IC. It is IL minus IC. What is IL? IL it is 1.2 minus 1. So it is 0.2 ampere. Yes, it is 0.2 ampere. Clear about this? So you have to take care about this series and parallel connections of resistor, inductor and capacitor. Clear? Again, in this chapter, if you know each and every equations, then you can solve questions easily. Okay, chalo now next question. Now next question, see, a fully charged capacitor with initial charge Q0 is connected to a coil of self-inductance L at time t is equal to 0. The time at which the energy is stored equally between electric and magnetic field is. See, here it is. Here it is. A fully charged capacitor with initial charge Q0 at time t is equal to 0. So at time t is equal to 0. At time t is equal to 0. Here I am writing this situation at time t is equal to 0. Total energy U is equal to, it is UE, means energy stored in capacitor, plus UB, energy stored in inductor. U is equal to, as a fully charged capacitor is with charge Q0, so its energy is Q0 square upon 2C. And we know that a fully charged capacitor, when it is connected to inductor, initially current flowing from inductor is 0. So its energy will be 0. So what is total energy? Total energy is equal to, it is Q0 square upon 2C. Okay? Hello? Okay. Now, we know about LC circuit. Okay, initially capacitor, charge on capacitor. For example, here it is. Okay, initially, this capacitor is connected with inductor. On this, initially charge was Q0. Now, as time passes, charge on this capacitor decreases, and current in this inductor increases. Okay, so I am assuming, okay, let when the energy is stored equally between electric and magnetic field, at that time charge on capacitor is Q. Okay, so I am assuming, okay, let when energy is stored equally, between the electric and magnetic field, between the electric and magnetic field charge on capacitor is Q. At that time charge on capacitor is Q. Okay, I'm assuming this one. Okay, again, capacitor initially fully charged, current from inductor is 0. As they are in connection, charge from capacitor decreases, current in this inductor increases, energy of electric field decreases, energy of magnetic field increases. So I have assumed that when energy is stored equally between the electric and magnetic field, charge on capacitor is Q. So at that time, what happens? See, okay, at that time when energy is equally stored means UB is equal to UE. Yes or no? Yes, we can write UB is equal to UE. So therefore, total energy. What becomes? Okay, U is equal to it is UB plus UE, and therefore U is equal to it is UE plus UE, and therefore U dash is equal to it is 2 UE. Yes, UE means energy stored in capacitor. So therefore U dash is equal to 2. UE means it is Q square upon 2C. It is Q square upon 2C. Clear about this? Any doubt? See, this situation is at time t is equal to 0. It is storing when energy is equally stored between them after some time. Okay, after some time. So yes, after some time, total energy is 2 Q square upon 2C. But according to law of conservation of energy, according to law of conservation of energy, initial energy U is equal to final energy or energy at any time U dash. So yes, it is Q0 square upon 2C is equal to, here it is 2 Q square upon 2C, 2 cut, C cut. So therefore Q is equal to, it is Q0 upon root 2. So when charge on capacitor is Q0 upon root 2, at that time, yes, energy is equally stored between them. So yes, this one you have to remember. Okay, when energy is equally stored between inductor and capacitor, at that time what is charge on capacitor? Charge on capacitor is Q0 upon root 2, means initial charge upon root 2. Now we know that charge on capacitor, its equation is Q is equal to, yes, Q is equal to, it is Q0, yes, I can write like this, Q is equal to, it is Q0 cos omega t. Okay, now in this equation you have to replace Qi. Q0 upon root 2 is equal to Q0 cos omega, means it is 2 pi t, and here it is t. Any doubt? Okay, now or take omega, no problem, it is omega t. Now Q0 cut, 1 upon root 2, yes, you know that cos 45, cos 45 is equal to, it is 1 upon root 2. So I can write it is cos 45 means it is cos pi by 4. Cos pi by 4 is equal to cos omega t. So I can write omega t is equal to, it is pi by 4. Omega t is equal to, it is pi by 4. Now omega, what is the equation of omega? Omega, it is 1 upon under root LC. Yes, for LC circuit, you know that omega is, it is 1 upon under root LC. T, it is pi by 4. So therefore T is equal to, it is pi by 4 under root LC. T is equal to, it is pi by 4 under root LC. Clear? So yes, it is your answer. Again, you have to remember the concept. Okay, and if you know this one directly, then you have to just remember this point. Okay, and yes, this one you have to remember. Yes, okay, whenever energy is equally stored between capacitor and inductor, charge on capacitor Q is equal to, it is Q0 upon root 2. Similarly, you can also obtain relation of current. Yes, you can also obtain relation of current. Okay, but it is most important one, that's why. Okay, chalo. Now next question. See, next question is, yes, it is on board. Impedance of the circuit will be, you are given one circuit, and see, in circuit it is clear, okay, with AC source having voltage 90 volt, one inductor and capacitor, they are connected in parallel. Inductor and capacitor are connected in parallel, having inductive reactance 30 ohm, capacitive reactance 20 ohm. Question is, what is the impedance of circuit? What is impedance of circuit? Okay, yes, there are two methods. First, you can solve this question with the help of phasor method. Okay, by drawing one graph, and another directly. How directly? See, here it is. As they both are in parallel connection. In parallel, V is same. I will write short. V is same. So what is current flowing from inductor? IL. Current flowing from inductor is, potential difference is 90, and inductive reactance of inductor is 30. So is equal to, it is 3. It is 3 ampere. Similarly, IC is equal to, chalo, yes, as they both are connected in parallel, so potential difference will be same, 90 divided by, here it is 20. So 0 plus 0 plus 9 by 2, it is 4.5 ampere. And it is 4.5 ampere. Now you know that when inductor and capacitor, they are connected in parallel. See, previous question. Okay, then now current from circuit, or you can say supply, current from supply, I is equal to, it is IC minus IL. Why minus? Why minus? Because phasor of IL and IC, they are in opposite direction for parallel connection. Yes, it is. So IC, it is 4.5 ampere minus IL, it is 3 ampere. So is equal to, it is 1.5 ampere. It is 1.5 ampere. And as it is connected across 90 volt, how to find it? Therefore, for the whole circuit, we can write, okay, I is equal to, it is V upon Z. So what is I? It is 1.5. What is V? It is 9. And Z, that is impedance of circuit. So therefore, Z is equal to, it is 90 divided by 1.5. So it is 90 divided by 1.5 into 10. Okay, so 15 into 6. 15 into 6, it is 90. So it is equal to, it is 60 ohm. So your answer is, it is 60 ohm. Yes, your answer is, it is 60 ohm. Clear about this? So it is how to solve MCQs. Okay, if you solve more and more questions, you will be clear about this. Okay, how to use equations, how to use relations and all. Okay, so yes, there are 4 MCQs. Yes, we will see some more MCQs. Okay, wait. Okay, now next question. See, an AC source of angular frequency omega is fed across a resistor R and capacitor C in series. The current registered is I. If the frequency of source is changed to omega by 3, keeping the voltage same, okay, the current in circuit is found to be how? Calculate the ratio of reactance to resistance at original frequency omega. E, B, C, D. You are given 4 options. Okay, chalo. From data it is clear that you are given RC series circuit. Yes, you are given RC series circuit. Okay, first of all, at angular frequency omega. है ना? चलो, what is equation? What is equation? Yes, we know that equation for current is I is equal to V upon, for RC circuit it is under root R square plus XC square, where XC is equal to, it is 1 upon omega C. है ना? Yes, where XC is equal to, it is 1 upon omega C. So yes, it is at angular frequency omega. Now angular frequency is changed. So what happens? See, if voltage is same, then there is no effect on resistance. Only XC means reactance changes. So at angular frequency omega by 3, at angular frequency omega by 3, at angular frequency omega by 3, reactance, new reactance, okay, new reactance XC dash is equal to 1 upon omega into C. Yes, XC means it is 1 upon omega C, angular frequency into capacitance. So I can write it is 3 upon omega C. But we know that 1 upon omega C means it is XC. So it is 3 XC. Simple. Okay. Okay. And in this situation, see, if the frequency of source is changed to omega by 3, the current in circuit is found to be how? Means how to write equation of current. What are changes? Current is how, means I have to write I by 2. V is same. Then it is under root. There is no effect on resistance, means it is R square plus, yes, here I have to write XD square. XC dash square. Any doubt? Hello, any doubt? Okay. So what happens? So chalo, here out I can write this as, if I put value of I here. If I put value of I, or if I take the ratio, if I take that ratio, it will be same. Okay, if I put value of I here, then it is V upon under root 2 into C. Okay, I have to put value of I, it is under root R square plus X square. It is V upon under root. See here, R square plus XC dash means it is 3XC. Its square means it is 9XC square. So see, V cut. So these two denominators, they are same. So therefore it is 2 under root R square plus XC square is equal to under root RC square plus 9XC square. Now take square on both sides. So therefore it is 4 R square plus XC square is equal to, it is R square plus 9XC square. So therefore it is 4R square plus 4XC square is equal to, it is R square plus 9XC square. Any doubt? Okay. So yes, add this side. So it is 4R square minus R square is equal to 9XC square minus 4XC square. 9XC square minus 4XC square. So therefore it is 3R square is equal to 5XC square. And now, as we have to calculate the ratio of reactance to resistance at original frequency omega. So therefore, XC square upon R square. XC square upon R square, it will be 3 by 5. And therefore, XC upon R, it is under root 3 by 5. It is under root 3 by 1. So it is how to calculate such MCQs. Clear? Okay, so yes, for today 5 MCQs, I think it is enough. It is, I think, lecture about 30 minutes. So it's okay. Okay, it's Okay, so yes, from chapter number 7 we have discussed at least minimum 10 MCQs. Now I will send you one. Yes, let me okay. Now I will send you one worksheet. That worksheet you have to solve. Okay, and yes, prepare these all MCQs for part A, MCQs part. Okay, because it is difficult for you. So do more and more practice. Okay, after practice you can also easily solve such questions. Okay, tada, bye bye. This is it for today.